This is an executive briefing on deploying Claude Code in the enterprise. Generative AI marketing routinely promises instant scale and effortless implementation. The architectural reality tells a much different story. Today, we're stripping away the vendor hype to establish absolute authority over how AI models must be governed in production. We are focusing exclusively on the uncompromising technical harnesses required to make these systems function securely within legacy enterprise environments. An unconfigured AI model is not a shortcut. It's a severe operational liability, and it requires meticulous governance.
Here is our structural sequence for this briefing. 1. A high-stakes executive overview. 2. A detailed operational postmortem. 3. Securing Phase A stability. 4. Process before platform. 5. The human blueprint. And 6. A chronological action plan.
Section 1. High-stakes executive overview. Governing AI at enterprise scale.
The core thesis here is that an unconfigured AI model operating within legacy enterprise environments is inherently dangerous. Consider the 30,000-line threshold. When a repository crosses that line, a default AI agent completely loses its mental map of the system. This is a highly predictable failure mode. Without a deliberate governance structure and a strict integration harness, these systems introduce unpredictable risk. The agent begins to blindly search for symbols. It returns thousands of false positives. It wastes valuable time reading dozens of completely irrelevant files just to triangulate its position. In doing so, it effectively torches its own context window. It drives up your computational costs exponentially before producing a single line of useful code. Governing AI at enterprise scale is not about simply trusting the algorithm. It's about defining strict operational boundaries, managing deep technical debt, and ensuring that every automated action is anchored by verifiable, tightly controlled architectural guardrails.
Anthropic explicitly notes that Claude Code navigates a codebase the way a software engineer would, by traversing the file system, reading files, and using grep to find exactly what it needs. That sounds great in a controlled sandbox, but this illustrates the severe limitation of default settings. That design choice functions adequately for a small weekend project. It entirely collapses under the immense weight of enterprise technical debt. In massive monorepos, a grep search is no longer a precision tool. It becomes a blunt instrument. It overwhelms the agent with noise. This proves that standard, out-of-the-box configurations are wholly insufficient for serious deployment. You can't just unleash a basic search function on decades of accrued code and expect clean architectural reasoning.
Section 2. Detailed operational postmortem. Technical debt versus vendor marketing.
We have to look past the vendor marketing to understand precisely why default AI agent setups fail at scale. So why does standard AI coding agents fail in codebases exceeding 500,000 lines? Surviving decades of accrued technical debt requires building a deliberate, layered configuration harness. In repositories exceeding 500,000 lines, standard agents fail because they treat the entire file tree as fair game. They lack the geographic understanding of where distinct services begin and end. When an agent lacks explicit instructions regarding repository boundaries, it wastes computational resources parsing node modules, generated binaries, and vendor dependencies that it should never have been permitted to read in the first place. This is the exact mechanics of context collapse. The distinction between amateur tool usage and enterprise-grade architecture is absolute. Consider grep-based pattern matching versus the Language Server Protocol, or LSP. Grep relies on simple text string identification. In an enterprise environment, that yields thousands of irrelevant hits across comments, legacy logs, and isolated modules. It's just noise. In contrast, integrating LSP provides precise symbol-level search. LSP actually understands variable scopes. It understands type definitions, imports, and inheritance chains. Demanding that the AI utilize LSP rather than grep ensures that an architectural lookup returns one canonical definition instead of 1,000 useless string matches. You're forcing the model to understand the structure, not just read the text. To prevent this context collapse, Anthropic's large code-based strategies demand a rigorous harness. You achieve this by deploying layered Claude.md files. These files distribute rules specifically to the subdirectories where they apply, rather than bloating a single massive root file. It requires directory-scoped initialization to anchor the agent's context window. You also implement repo-root codebase maps. These serve as wayfinding tools, offering one-line descriptions of top-level folders. Furthermore, implementing version-controlled permissions.deny lists permanently locks the agent out of sensitive build artifacts. Finally, you must use subdirectory-scoped test commands.
This prevents the agent from triggering global test suites that take hours to run, which would otherwise paralyze your continuous integration pipeline.
Section 3. Securing Phase A Stability. Baseline Core Integrity. Before any complex optimization or workflow automation occurs, the baseline core integrity of the deployment must be absolutely secured. Examining the 4 distinct Claude API integration patterns is critical for this architectural alignment. Synchronous requests are optimal for interactive coding applications. However, they carry standard token costs and high latency profiles. Then we have asynchronous batch processing. This is mandated for high-volume log or document analysis. It operates on a 24-hour service-level agreement, but it delivers a massive 50% cost reduction. Next is event-driven architecture. This triggers seamlessly from IT service management tools, providing invisible, native integration directly into your workflows. Finally, agentic pipelines. These are strictly reserved for complex, multi-step legacy code-based refactoring, where sophisticated state management is explicitly required.
Security architecture requires uncompromising governance rules to avoid hard-coded vulnerabilities. Development teams must enforce a strict policy of one master API key per environment. These credentials must be stored securely in AWS Secrets Manager or HashiCorp Vault. There is no flexibility here. A mandatory 90-day automated key rotation schedule must be enforced without exception. Furthermore, routing all traffic through centralized proxy layers provides the necessary audit logging. Single sign-on and role-based access control ensure that access is strictly compartmentalized based on verifiable enterprise identity. We do not layer artificial intelligence over broken operational foundations. We secure the baseline first.
Financial oversight is a non-negotiable component of enterprise architecture. Look at this figure. By implementing strict prompt caching for large, stable context blocks within production environments, organizations realize a 90% cost reduction. When an integration relies on repetitive multi-document analysis or massive stable system prompts, leveraging caching changes the financial equation entirely. It shifts the deployment from an unpredictable runaway expense into a highly optimized, economically viable engineering asset.
Section 4. Process before Platform. The Integration Playbook.
We operate strictly under the principle of process before platform. Automating broken workflows only scales inefficiencies and accelerates institutional failure. The process itself must dictate the platform architecture. We must interrogate the underlying operational mechanics, ensure they are logically sound, and only then apply the AI integration playbook. This is where the Model Context Protocol, or MCP, provides a critical standardization layer. MCP servers deliver a standardized, secure interface that allows the AI agent to read and write data directly across the enterprise tech stack. And it does this without requiring brittle, custom-coded API bridges. Whether you're connecting to SAP, Oracle, or NetSuite, MCP routes the AI's request through a unified protocol. This ensures that data traversal remains secure, auditable, and structurally sound.
The leverage gained through integrations like the Composio NetSuite MCP and SAP BTP is substantial. We observe highly strategic automated workflows. This includes the automated generation and management of invoices within NetSuite. In SAP environments, agents handle complex BTP CAP application data modeling and database schema exports. The protocol also enables real-time inventory control tracking and the direct execution of Suite Analytics datasets. These aren't just trivial administrative tasks, they represent deep operational integrations that drive measurable business velocity, assuming your initial ledgers and data migrations were clean to begin with.
Section 5. The Human Blueprint. Combating Change Fatigue.
Architecture without psychological alignment ultimately fails. The human blueprint requires us to combat change fatigue aggressively. We must position AI not as a replacement for high-tier engineering talent, but as a protective layer against operational burnout. We have to deliberately protect developer identity capital. Engineers define their professional worth by solving complex architectural challenges. They don't derive value from migrating legacy database schemas or manually translating internationalization files. By delegating these historically tedious, low-value tasks to the Claude code agent, we drastically reduce change fatigue and user resistance. This delegation preserves the engineer's psychological stamina for tasks that genuinely require human architectural reasoning.
To make this work technically, a strict operational divide must be maintained to preserve context. We separate code-based exploration from active editing. Exploration subagents are spawned in a read-only capacity. They are given fresh context windows to traverse the relevant architecture and produce a highly focused diagnostic report. The editing parent agent then receives only the summarized intelligence. This leaves the parent agent's context window clean and fully available.
It can then execute precise structural modifications without suffering memory collapse halfway through a complex task.
Concrete examples of this efficiency are evident across multiple enterprise platforms. Tasks that previously required massive manual effort are neutralized. Localized I-18 translation file generation is now completed in minutes. Agents handle automated pull request reviews seamlessly, integrating directly into GitHub CI/CD pipelines. They reliably export complex database schemas directly to HTML or PNG visual designs. Furthermore, they instantly generate the structural boilerplate required for custom Odoo ERP module scaffolding. This eliminates hours of tedious setup work and lets your senior talent focus on strategic execution.
Section 6. Chronological Action Plan. Deployment Guardrails.
We've established the theory and the mechanical requirements. We now transition to the final phase-based architectural blueprint. This chronological action plan establishes the precise deployment guardrails necessary for scaling this technology across a mature enterprise environment without compromising security or operational stability. Phase 1 mandates immediate secrets management integration, eliminating all hard-coded vulnerabilities. Phase 2 requires the establishment of a centralized proxy and strict audit logging setup for total traffic visibility. Phase 3 initiates the deployment of the harness itself, featuring layered context distribution and the LSP-MCP rollout for precise code-based navigation. Finally, Phase 4 achieves full CI/CD pipeline automation, deeply embedding the agent into the core development lifecycle.
The strategic allocation of AI agent computational resources in a mature deployment is deliberate. Look at this distribution. 40% of the computational bandwidth is assigned to tedious task automation, which directly protects human capital. 30% is dedicated to complex system integrations via MCP servers, routing data securely through systems like SAP and NetSuite. 20% targets active core legacy refactoring. The final 10% is explicitly reserved for read-only exploration subagents. This ensures the system continually maps the environment before attempting any deep structural edits.
We reiterate the absolute necessity of financial oversight as usage scales. Transitioning high-volume, non-interactive workloads to asynchronous batch processing guarantees a 50% cost reduction. Executives must demand this architectural routing logic from day one. Allowing development teams to default to real-time, synchronous processing for massive background analysis jobs demonstrates a severe lack of financial governance. It will inevitably lead to unacceptable billing spikes.
We leave you with a definitive operational mandate. You must assess your current posture. Is your enterprise meticulously configuring a deliberate AI harness, complete with strict boundaries, layered context, and precise LSP integration? Or are you simply letting algorithms blindly grep through decades of accrued technical debt? The marketing hype is irrelevant. Only rigorous architectural discipline dictates whether AI becomes a scalable enterprise asset or a catastrophic operational liability. The choice of governance is entirely yours.